Hello, everyone, and welcome to another Into the Terminal. Today, we're going to be talking about the top 5 problem indicators for Linux. So, this is like, what do you look for to know that your machine may be having some problems? Joined as always is my fancy dancy co host, Nate Lager. And Nate, you're going to kick us off today talking about a common problem indicator.
Fancy. I I don't know how to. You broke my brain. I don't dance. Anyway, except in the terminal. All right. So number one thing, right? Disk. That's probably I mean, in my experience, the number one thing that an admin has to care a lot about and has to deal with frequently, right? So you definitely want to monitor disk, but it's not necessarily easy out of the box. Right? Sure, you can log in and check disk usage. One recurring theme I think we're going to touch on a number of times today is monitoring systems, right? You can employ some sort of a monitoring system that will check for disk. But what if you want just like something simple that'll show you disk? So of course, good old DF will tell us what's full, what's not, whatever. That's not great for monitoring though, because you don't want to have to log into your systems and check disk. That just is not a good use of anybody's time. So I did some research on our own knowledge base, and I found this older article, which is linked in the notes today, about monitoring disk. And I'm not going to share that specifically because I don't want to mess around with screen shares and whatnot. But it's written for RHEL 5 and 6, so it's a little dated. But the script that's in it is actually pretty useful. We're going to make a new script here. And I'm just going to paste this in, right? This is right from the knowledge base article. You can see it's setting a variable based on the output of df. You can see it's calling slash directly. It's looking just for the disk usage of slash. So this isn't exactly it doesn't incorporate every disk that's on the system. And then what this is designed to do is it sends an email if it's over a certain threshold. So we're just going to drop out the email part because we don't need to send an email. We're going to replace it. Oops. Hit the wrong key somewhere. We're going to replace it with an echo. And I guess I could have used the end key instead of scrolling all the way like that. I'm just going to go like that. And I did notice that I guess the output, the columns in the output of DF must have changed between RHEL 5 and 6 and the current RHEL 9 that we're on right now, because $4 in this awk is not the right column. So we're going to change it to 5 because it is the right column. I tested this before. So, right, what this is doing is it's checking DF, it's passing it through awk, passing it through sed to take off the percentage so you get a clean number at the other end. It sets that to current. Then it compares current to whatever your threshold is. And in this case, the threshold is 90. That'll come out to 90%. And then it's just going to tell me, hey, there's a problem here. It's too low. So we're going to write this. We're going to make it executable. And then we're going to run it. You see, it returns nothing. That's because there was nothing to report. If we were to go back in there and change that threshold to like 10, I think 10 will do it. Now it'll tell us, hey, it's 17% used, right? Obviously, 17% isn't a problem, but for the sake of demonstration, this works out good. However, like I said, this doesn't scale all that well unless all you care about is slash. Most people, they'll have several partitions on a system. It's not just slash they care about. Even on a very basic deployment, you'll have boot and slash, probably temp maybe. And there's a couple other file systems that are virtual file systems that maybe you don't care so much about how much you're utilized, or remote file systems. Say you've got an NFS share or something like that, and you don't care about those so much. So what we've got here is I made an improved one. We're just going to call it disk check improved, right? And what this does is we set the threshold to 90, same as we did in the other script. And then I've got a for loop here that takes the output of df-l, which tells df local file systems only. I take out the header by grepping -v for the word file system, which is one of the headers. I did look. DF does not appear to have a headless or a headerless output. If there is one, then you could replace that with the flag there. I couldn't find one. And then I put it back in through awk, right? In this case, we're doing print $6, which in the DF output is not the space, but it is the mount point, right? And we're passing that through this for loop. The for loop does a df, basically does the exact same command we did in the old one, df, except this time we're passing in what mount point to look for. We're looking just for that mount point again so that we get rid of the header. And then we're awking for column number 5, and we're taking out the percentage. And then this will give us an output for every mounted file or every mounted file system. So let's run that one. It's check improved, and it should tell me, oh no, slash mount is over 90%, 97%. Now, again, this is just outputting to the screen. What you would probably do is take this similar script, modify it to do something else that's going to alert someone, whether it's to send an email, log it somewhere so that your monitoring system can pick it up later, send it into your log analysis system, whatever. Do something other than just output it to the screen. But for the sake of example, this is that. And now if we look at df-h, you can see right here, I made this virtual file system down here, which is just mount under slash mount, and it's 97% because it's tiny and I filled it up with a bunch of zeros. And there you go, disk monitoring. Very important thing to monitor, because if you have something like a database or files that get written to a file system and it fills up, can very quickly lead to file corruption. Not file system corruption, but database corruption, for example. If that's a database that was written on slash mount, ran out of space in the middle of a write, bad things happen. You don't want that to happen, trust me. All right, there you go. Disk monitoring. Any comments, Scott? How would you have done it different?
Well, I was keeping up with the chat, so
Oh, good.
Alerting, like we were talking about setting your monitoring system to alert at a certain percentage, right? So, Shantanu pointed out that it's all good if you know how much you're used, but if it's like 97 or 99% full, you may not have that much time. So that's probably not a great
Right.
threshold to start alerting at.
Oh, absolutely. And the size of your disk matters. If you've got a 28 terabyte disk that's 98% full, you might still have terabytes of data available. So you might set that threshold a lot higher. However, on some large disks, they're large because they get a lot of data written to them very quickly. So that'll also change where you want that threshold to be, right? But if it's a small file system, you may want the threshold to be a lot lower, because it'll fill up a lot easier with smaller files, right? So this is all very subjective based on what you're doing with your system and what you care about, what you're monitoring.
All right, so I think that brings us to the end of the critical path.
I
So
think it
don't
does.
forget, if you like this content, to like it and smash that subscribe button so you can know when we're doing these things in the future. If you know somebody that might also be interested in 4 more top troubleshooting or top problem indicators for Linux, share them this video, and we'll see the other 4 coming up. We're talking about memory, logs, uh, load average, and then I'm missing one. What's the other one? Oh no, that's it.
Number of processes.
Disk. Oh, processes. That's right. So stay tuned as we delve into more top 5 problem indicators for Linux. All right. So Nate, I think you alluded to this in your critical path, which was monitoring, and you said we'd be talking about monitoring a few times. Why was that?
So, I mean, obviously, if you have a fleet of more than, like, I don't know, one server, it gets to be difficult to keep an eye on all of them at the same time. So what you need is an automated system that's going to keep an eye on it for you. Now, there's a bunch of products out there, some of them free, some of them open source, some of them for pay. Pick your poison, right? We used to use one called Nagios, which has a free open source version and a for pay supported version. There's a bunch of others out there. I've experienced the number, even some in-house written ones over the years, which basically will automate checking for disk usage, checking logs, checking all the things we're going to talk about today, plus many more.
Yeah, and so I have also used Nagios. But more recently, I started using Zabbix and really enjoyed it. Like Nagios has a um, open source community version, and then they also have a pay for support version. Um, and then there are a couple others out there too. So in the chat, if you're using one that you like, I would say throw it into the chat to let us know what monitoring solution you're using that you enjoy, because we're
Yeah,
always looking for new ones, right?
Big Brother. I used one called Big Brother for years. I don't know if that's still around anymore. Super simplistic.
Yes, I actually worked on a Perl port of Big Brother.
Oh
You're
yeah?
welcome. Yeah, yeah, that's a long time ago. Uh, all right, so why don't we hop into our next thing, which is a top problem indicator. So here we're taking a look at this box, and I've messed up this box, and we can see that it's messed up because if I look at the uptime, which reports like how long it's been running, but it also includes the load average. And so we're looking at the five, I'm sorry, the 1, the 5, and the 15-minute CPU run queue depth. And so my load average is 50. For those who are inexperienced, that's pretty high.
Yeah, that's
It
pretty
means
high.
I have 50 jobs in my CPU run queue. Now, if I had 50 CPUs, maybe that's cool because you
Right.
get one per CPU and everything's good. That's not what this box is, though. It's a dual CPU system. So this means that for each CPU, there's 25 jobs waiting to run on it. Why this is potentially bad, right? I say potentially on purpose. Because with that many jobs in the run queue, periodically the kernel has to stop and look at what is running on the CPU and what is in the run queue and swap out what's running so that everybody gets their fair share of compute time. So the higher your load average, the more of those context switches your kernel will be applying to your system. And actually, on this system, I tried to install some software while my problem was here, and it was definitely super sluggish because that DNF install had to wait for its turn to come around for some CPU time. And then it gets a certain time slice, and then it gets taken off, and the next thing gets put in its place. So the higher the load average, the more that could potentially be the case. The other thing that's going to tie into this is what are those things actually doing? So if they're actually CPU intensive compute jobs, um, the higher the load average, the more CPU time is being used. With your, in this case, these jobs are actually not very CPU intensive. Um, so that's why I can still run commands like the ls command, and it comes back pretty quickly because these jobs are not super CPU intensive.
Right.
But if it was CPU intensive, like you might run that command, it might take like you type in the command and then you see the L show up, and then you see the S show up, and then there's a long pause, and then the output shows up.
Yeah.
Uh, yeah, so that's
Because
the
your command is basically waiting in line for the CPU. So I guess to frame that, what Scott's saying here is if these things process quickly and there's 50 in queue, that might be 50 milliseconds, right? Because they process quickly and they're back out of queue. And then your thing is in line, right? But if they take a minute each to process, that's 50 minutes, right?
which we actually don't. Well, we use a kernel tunable for determining what that scheduling granularity should be, how often the
Okay.
kernel check to see if it's there. But
Yeah.
yeah, like CPU intensive jobs are gonna make things harder.
Right.
Also, jobs that are not scheduled in the CPU, like you lose CPU cache, it gets put over in the other CPU. Like there's a lot of weird stuff that starts to happen when you are running heavy CPU load on a machine. Okay, that's it. So yes, this can indicate a problem. But most of the time when I see this, it's actually not a CPU problem or even a application problem. So Nate, I don't know if you've ever seen this before where it's not been a CPU or application problem.
It could be a disk problem as well. If the disk is taking too long to read or write.
And that is overwhelmingly what I have found to be the case when I've
Yep.
experienced this in the real world.
Especially
Uh,
with remote file systems.
well, yes, because there's something going wrong and we're not able to do those file operations. And
Yeah.
so the job that requested a file read or a file write, well, file write, actually, let's take that out. The job that requests a file read makes the request to do a read, but then is blocked waiting on that data to come back before it can operate on it. And so
Yep.
it's in the CPU run queue, and when it gets its turn for its time slice, it checks to see whether its IO has resolved, and it hasn't. So it goes back to sleep for the next round. And
Yep.
so, like what we saw here, where I was typing commands and it was pretty resilient, that's because the jobs aren't CPU intensive; they're something else intensive. And for disk IO problems, you'll get a similar behavior. The load average values will be crazy town, but like the system seems fine, and it's because you have all these jobs blocking on IO things. So Nate mentioned network file systems, um, SANs, like places where your machine is reliant on other machines, is where you want to start checking for that kind of situation.
Or even really anything that depends on a network connection, right? If the network is slow, if this is a database server and there's a million requests coming in and the network is slowing them down, that can also cause this. Things like that.
Yeah. So some other places where we can go for data on this problem. So I showed you load average, but you can also see that in the top command.
Hmm.
And here you get a little bit more information because not only do you get that load average there at the top, but you also actually see the topmost jobs, and it defaults to those that are running first. And so we actually see my 50 jobs that are running are DDs. Um, and you get a
Somebody's
little bit,
just destroying your disks.
no, thankfully. Um, and maybe after the show, I can tell you guys what I did to make this change. All right.
And we
So
talked about disk weight. Maybe you're going to cover this, but there's a column right there at the top that tells you what it's waiting on, like where things are bound up.
yeah, under CPUs,
Right.
this line item right here, it tells me where my CPU time is being spent. And so if it is a disk IO problem, you probably will see a bunch of stuff in the WA field, the wait field, telling you that your jobs are running, but they're sitting in the CPU wait field, and that's the problem. Um, Normally, you expect to see jobs either in user or system. Those are the first two
Right.
fields. Things like the others, idle, wait, nice, swap in. I think SI is swap in. I don't remember what ST and high are, but those are less frequently the case. All right. When I kill off my jobs,
Look at them all dead.
so they're all dead, and notice that my load average started to go down pretty quickly in that 1 minute field, that
Yep.
first field. But it's going to be 5 or 15 minutes before it goes down in the other fields. The
Yep.
other thing is, this was running for about 15 minutes, but it wasn't 50 at the 5 minute and 50 at the 15 minute because it's not just the raw count of runnable jobs in the run queue. It's actually the amount in average across that time period with a logarithm mathematical operation applied to it. And the reason they do that is to kind of, if there's a spike, they don't want that spike to throw off the averages for these longer time periods. And so by logging it,
Right.
when I say log, I mean logarithming it, you can smooth out any of those bumps to get a more consistent long term view. All right. So back to monitoring. So monitoring load average is also something that's fairly common. And again, when you get
Mhm.
those alerts and you log on the machine, you need to figure out like what's really going on and whether you really need to care about that. Again, when you have systems that are larger with larger CPUs, you might want to change your monitoring profile for that system to account for that larger amount of hardware. So if you
Yep.
have a high load average in number, but you also have a high CPU count, that might not be bad.
Yeah. Yeah, we had a database box that had like 128 CPUs in it. And, out of the box, the load average monitored or alerted at like 2 or 3. And it's like, well, no, that's totally not a problem for this box. So yeah, you definitely have to up that based on how many CPUs you have and what's an acceptable load average, right? Maybe 100% utilization is acceptable, and you don't want to alert until it's like 150%, right? So just keep that in mind.
So Nate, you're going to talk to us some about logs.
Yeah, we went and switched the screen share, and I didn't even realize. So yes, logs. Um, You talked about log rhythms. We're talking about log files now. Not to be confused. So logging is an important thing, right? As services do things or services have problems, they generally write out a log file. Or in the system D world, they'll write to the system journal, which actually adds another layer to this conversation, which I'm going to try to go through quickly before I actually have my demo here. So in varlog, you're going to find a bunch of log files. Things like varlog messages are like a general system log. There's a number of others, like Apache might be logging to varlog HTTPD. There's a log there for cron. There's a log there for people who've logged in and logged out. There's a log for people who may have failed logins or succeeded logins, which might actually be a thing you might want to monitor for if accounts that aren't supposed to be logging into your system have successfully logged in, or they've logged in from a place you don't expect. That's a thing you might want to be alerted on, right? Um, but there was one more point I wanted to make there, and I'm trying to remember what it was now. But the logs are an important thing to watch. And there's certain keys you're going to want to look for in those logs. Stuff like the word error, the word warning, OOM. Who's got nightmares about seeing those in their logs, right? That means you're out of memory, and the killer has come by and started killing off processes seemingly indiscriminately, even if that was your database workload, to free up system memory to keep the system from going down and crashing. So these are all things that you might want to watch for in the logs. If you see in your logs, that probably means you need to take action like now. But if you're monitoring memory usage, which we're going to talk about in a minute, hopefully you can get to this before you get there, before you get to the killer killing stuff off on you. I mentioned systemd and the system journal. Those you can configure systemd, the journal that is, to pass off to rsyslog. And then you can use rsyslog to send those logs elsewhere or to write files, right? So that's another point to talk about for logging. It's common practice nowadays to send those logs off system, because if you have someone that's a bad actor, they may try to clean up their tracks by deleting their stuff from your logs. If you're sending them to a third party, I don't know, let's say Splunk or a file share even, you now have a second copy of those logs. They are a lot harder to tamper with, right? So just keep that in mind. But the system journal, like I said, is kind of in memory in like a binary format. So unless you've got that configured to write out to syslog, that may be a little harder to monitor with your monitoring tools, because your monitoring tools are probably going to expect flat files. Now, maybe in today's world, there's monitoring tools that will directly read the systemd journal. I'd be surprised if nobody has tried to solve this problem. But just a thing you're going to want to keep in mind. There are certain things you'll find in the systemd journal that are not in the text files, right? And vice versa. There's stuff in those files that aren't in the systemd journal. So keep those both things in mind. All right. So now that I've had my terminal up for so long and haven't done a thing in it, we're going to actually show you a tool. This thing's old school. And Scott, I don't know if you've got any suggestions on an updated version of this. I tried to find one and didn't really come up with much. But there's a tool called Logwatch, which used to come out of the box on even the most basic RHEL install. Now it's a thing you have to install extra. So we're going to go ahead and install it. I don't know why I always want to add an R to the word watch. Logwatch. I don't know. Anyway, it is based on Perl, as you might notice, which could be why it doesn't come out of the box anymore, because it is an older tool. But Perl is known for being really good at parsing text, right? So you can understand why this might be a Perl tool. Now, Logwatch has a bunch of configurability to it. It's designed to run periodically and send an email. but you can use it for other things. And I'm going to show you a quick example here of just running logwatch from the command line and telling it to show me the status of all of my services. Just to give you an idea of what it does. Let me clear my screen here quick, and then we're going to paste. All right, so I'm telling logwatch to give me a high detail of all of my services. Now you can configure logwatch as to what logs it monitors and what kind of alerts it's supposed to send and things like that. But this is just a good overview of like the sort of thing that you'll get out of logwatch. Here, it's showing me network routes. That's a thing you might want to watch for. If there's a new network route that shows up on your servers, why did that happen? Or if a route went away, why did that happen? Right? These are bad things. Um, the sockets that are listening, another thing that you probably don't want to see change frequently. I've seen some folks actually periodically scan their network to see if new ports have opened up or not. This is another layer of defense against that. This is what network interfaces are there and what their statistics are. If you see anything weird happening in those, you're going to want to know about it. Here's our good friend, the disk space usage, right? Um, the system configuration, like how much memory there is, not just available, but how much actual memory that is there. If a memory stick fails and you miss the alert that it has failed, you'll see the total memory here change. If all of a sudden the memory is less than it used to be, then you'll know something weird's going on, right? So yeah, logwatch, old school. Like I said, there may be newer tools. I couldn't find one that came out of the box with RHEL. There's a bunch of other projects that do similar things, but this is great. Just it's good that it's included.
Yeah, and a lot of the monitoring software will also allow you to look for specific keywords.
Hmm.
So you mentioned like all lowercase,
Yep.
um, is good. Then there's also things like error and warn, and you want to mix your capital and lower because sometimes, depending on what it is, it might use different cases.
Right.
But that might get a problem.
Yep. So yeah, logs. Make sure you keep an eye on your logs.
All right, so next we're going to talk about memory. Speaking of out of memory, we just did. So I've broken my system yet again. Eric loves Manager Scott, who breaks systems all the time. And what we're going to take a look at is free. You know what? I'll do a free with human readable sizes. And so what we're looking at is a machine that's got about 4 gigs of RAM, and 3.2 of that is used, and we only have about 400 megabytes unused. Um, that can cause problems, right? Because as new jobs start up, they need memory, and if I don't have enough memory, that can cause issues. But on the good side of that, I also have some shared buffers and cache and available. So of that 431 that's there, 405 is actually like available whenever anybody uses it. And then I have 10 megabytes and 190 megabytes used for shared and buffering and cache memory. If you run out of available memory, we will actually deduct stuff from cache and actually sync things out to disk and other things to try and free up that memory and then put it back into the available slot. But this machine is pretty close to full. Another utility that we could use besides free would be VMstat.
There
And
was a
maybe I will.
time when the free tool didn't make it obvious that those buffers and cache were eating up memory, right? So unless you knew what you were looking for, you might think your system was out of memory when actually it was just this stuff that was in buffers, which could be freed up for use, right? So
Yeah, and
old
and honestly,
school.
that's a more recent change. So
Yeah,
on your RHEL 7 boxes, it probably does not report the available in your free, or I should say, it doesn't report the buffers and cache and shared memory as part of the free memory that's in the free column.
right.
All right, so here with VMstat, by the way, you can also run this with some timing, and it'll actually just like run this periodically for however many runs or whatever time you told it. I used the size option to have it report the size in megabytes instead of K. So just like before, we can see our free memory, that's our available memory, is 451 megs. And then we're using 199 megs for cache. Um, And then there's some other stuff that gets reported in VMstat, like IO information. So the BI and BO are blocks in and blocks out. That shows you your disk reads and writes. Um, and then your CPU times, right? US, SY, ID, WA, ST. Those were the things that we saw on top earlier. So you get a little bit more information here. And then we also get the information on swap usage. That's under the swap D column. All right. So what do we do about having not a lot of memory? Well, one of the things we might want to do is figure out who's using it all. So we can do something
Right.
like process status. And we want to look at either the percent mem, that'll show me the overall percentage of memory this process is using, or you might look at the VSZ RSS columns. And so when we come down here, we see that poll kit's actually, its virtual size, its VSZ is pretty large, but its resident size, how much it's actually using in RAM, is not super crazy. If we keep going, I think here's my problem right there.
That
So
that
this has
stress
a
NG supercritical application is eating up all the memory again.
shush. Don't keep secrets, Nate. Um, so its virtual size is about 2.9 gig, and its resident size is also about 2.8 gig. And often it's the case that the virtual size and the resident size aren't going to line up. And the difference between the two columns is virtual size is how much the application requested for memory. And the resident size is how much it's actually storing in memory. And so a lot of times applications will ask for a bunch, like we can see this one right here. Right, this process asked for about 725 megabytes of RAM, and that's what was added to its address space. But it's only using about 21 megabytes of that RAM. So that's a pretty
Right.
common thing to see. And there's a lot of reasons why that is. Some processes manage their own memory stack, variables, content. Databases do a lot of that with caching and other stuff internal to their application. It might be that this machine doesn't know that there's other shared memories, or sorry, shared libraries available. So when it allocates
Mm.
its space, it allocates it assuming that its shared libraries haven't been loaded yet. Well, we had already loaded those, so we can link them up in system memory and make sure there's one copy of the shared library running for everyone, as opposed to every process having its own copy. So those are the things that create this disparity. All right, another place where we could go to see this is our friend top. And notice here it's like loud and proud. Stress and G, that's my problem right there. Um, and again, we see the virtual size, that's how much memory the process is asked for, and its resident size, how much is it actually consuming out of that requested amount of memory. And then there's one more field, which is shared memory. How much is it using of shared cross-linked between processes memory? All right, so Nate, why is it a problem if you have this process that's like using up all your memory?
Well, I mean, obviously, memory is a shared resource, and if there's not enough of it, things can't run or things will eventually be killed off.
Yeah, Un killer is the big danger,
Yeah.
right? Because so let's say you run out of memory. Um, the out of memory killer kernel thread will start up, and the way that it solves your problem of not having enough memory is by killing off processes until you have enough memory.
Yeah.
Trick is, it's not really choosy about what it kills. So it could kill your SSHD daemon. That freed up some memory, but now you can't remotely access this machine anymore, and you're putting your rear end in your car and driving to the data center, or calling someone who's at the data center to go touch this machine.
No, you
Uh,
obviously connect to the ILO and get a console.
Potentially, unless it's killed all the Gettys.
Exactly. That's the thing
Don't
I've run into where it's oh, killer fired up. It tried to do its job, but the console is left inoperable, or SSH is left inoperable, or you can SSH in, but Bash can't get enough memory footprint to launch, right? So this is why you don't want to end up in this situation. Killer is a great concept. It's a great theory. I've never actually seen it save a system that I could get into it and and actually work with it though.
So funny you should mention that. I wasn't going to cover this, but since you brought it up, you get to go to my favorite file system, proc. All right. So every process has this directory in proc to keep track of all of its stuff, including its memory and a whole bunch of other stuff. But two things that tie into our current topic. So will actually look for things and kill them off based off their score in their process ID directory. So this one, it is going to be killed if there is an situation because it has no
Right.
score. It means it's ripe for killing off with killer. So there's also the score adjust or adjust, both of them. Oh, that's actually not good for this one. How do we do this? Oh man, of course I picked the wrong one to try this out on. So what you
Going
can
off
do is
script, Scott.
I know this is what happens when I don't test. That's 498. Okay. Doing the same thing. Yep, same. What I really need to do, Nate, is do a pid of SSHD. Here we go.
If you don't test the system will test you. This is true.
Killing me. Killing me. So normally there will be some out there with some score. And when you adjust them by using either adjust or score adjust, it'll change that scoring. And the higher the number, the less likely it is that is going to kill it. It actually prioritizes based off that score.
Right.
And I'll have to figure out why I'm not getting any score on this box. But
Maybe it's a syntax or something. I don't know.
so what I've seen people do in the past to protect them is in their systemd unit file for something like SSHD, they'll stick in a script to go and tweak the
Adjust
adjust.
the score.
Right. So every time we start up SSHD, it automatically gets this adjustment to keep it large.
Right. Right. Good idea.
Yeah. But otherwise, it's just going to like kill at random, seemingly at random, until it gets something that makes enough memory. So, like, let's say you have a Java application that is misbehaving. It's just going to kill off a bunch of stuff until it eventually gets to that Java application, which frees up all the memory and everybody's happy again. But all the things up until that Java application probably made you very sad. All right, so that's a little bit on memory usage. Rounding us out, I think. Processing.
Yep, we have one more. This one's pretty short, so we are over, but we shouldn't be too much more over. The number of current processes, right? So, I mean, you might wonder, why would I care how many processes there are? As long as my system is performing well, as long as there's no issues with my system, why do I care how many processes are actually running on my system? Well, because if there's a sudden change in process count, whether it's dropped significantly, that means a bunch of processes just died, or whether it's raised significantly, that means a whole bunch of processes just spun up, right? These are things you're going to want to know about. And this is going to be different based on what your workload is and what runs on the machine. But I'm going to show you how to get the process count. Now, PS, unlike BF, does have a no headers flag. So we're going to drop off the header just so that there is one less line for me to count. We're going to do AUX, which is basically how you list all of the processes on the system. It gives you more information than you're really going to need. I think PS-A would probably be enough to get this done. And then we're going to pipe it through word count with the -L flag, which says don't count the words, count the lines, right? And it's going to give us a number, 97. If what you probably want to do is when a new system is built and you want to monitor this, you might want to let it run for a little while and get an average of what that number of processes is going to be, right? Maybe it's 97, maybe it's 110, maybe it's 200. I don't know. It's going to depend on what it is that you're running and how many processes it spins up to do its workload. And then you can use this number as a thing you feed back into your monitoring system, and you can say, if this number is significantly different, right? Let me know. And then you'll have a reason to go look and say, well, why is it different? Is it just because the system's under heavier load? Maybe you care about that. Maybe why is it under heavier load? Maybe it's just random, course of business stuff. Maybe someone has run some not so great processes on your system and you're going to want to know about that. I'm always paranoid like that, Scott. I don't know about you.
So Nate, you would use this to kind of suss out somebody maybe running malware?
You could. You could. Now, sometimes that's just one process and you're not going to see it, right? But if it's like a Bitcoin miner, it might spin up as many processes as you have CPU cores, right? So that you'll probably notice. If it's like a 32 core system and all of a sudden there's 32 more processes, that's suspicious.
Yeah, I would smell a acceptable use violation there.
Yeah, right, right. Well, I mean, I've seen attackers do just that. They'll break in through a web application, and all they did was drop a Bitcoin miner because everyone's trying to get rich. And
Right.
yeah, so that's it for that demo. I don't have much more to show there, but that's how you would check the number of processes. And like I said, you're not going to want to key directly on. Oh, it said 97. 97 is the threshold. No, you want like a little buffer in that because that is going to fluctuate based on what the system's doing.
So something else where I've seen this change significantly, especially when we talk about monitoring systems. So monitoring systems will often check the reachability of an application or a system, but it doesn't just like keep in constant contact, right? It waits for check-ins or maybe it'll run a ping periodically to see if the machine's there. So I've seen it where somebody has rebooted a machine and a check like this starts alerting because it didn't miss a check-in or didn't miss enough check-ins as part of its reboot, but it
Right.
changed its processes because now there's less processes or
Yep.
kind of wasn't in the norm. And so there have been a couple times in my real life where it's like, what happened to this box? And I start investigating it,
Yeah.
reboot it, and then I have to figure out who rebooted this box and calmly discuss it with them.
Yeah. The some monitoring systems, they're going to be more sophisticated than just doing a PSA to AUX and then keying on a threshold. They have like a scale where, as a system's running longer, sometimes this will increase, right? The number of processes that are running because things are running in the background and whatever. But a freshly rebooted system, of course, that will kill off all those things. So just what you're saying, right? Maybe that has grown over time and all of a sudden it dropped. And now that it's dropped, that's a thing that it alerts on, right?
I'm looking at the chat, and Shantanu wanted to make sure that we pointed out inodes for
Oh,
DF
yes. Yeah. What is that? DF dash
minus that.
I, isn't it? God, I'm clicking in the restream window instead of my terminal. Dash I, right? Yeah, that'll give you inodes. So you could fill up the inode table of a disk and not fill up the free space, right? I've run into that before where why is the disk full? Right? If you do a df-h on it, it'll show you the free space and it'll say there's still free space, but it'll say you can't write a file. And I don't know if that's changed over time, but it used to be that it didn't give you anything different than just no free space on the file system. It didn't say it was the inodes that were full. It would just say there's no space. And you'd have to know to go look for inodes to see if that was what was causing it or not. And the inodes, if I remember correctly, are tunable. You can change the number of inodes in a file system when you create it. So if you know that your system is going to have a lot of tiny files, you might want smaller inodes versus larger files. You might be able to get away with larger inodes.
Yeah, so the error message remains the same, no disk space available.
Right.
Uh, the other thing to think about is number of inodes are fixed at creation time on the extended type file systems, so ext2, 3, and 4, but they are not fixed for XFS, which is the default file system for RHEL.
Right.
Um, XFS will, as it sees that we're running out of inodes, will actually convert data blocks to new inode table entries.
That's
Um,
handy.
yeah, so it may be less of an issue as we move into the more down the XFS road.
I knew we
Uh,
liked XFS for a reason.
yeah, and then in addition to like a ton of small files, the other thing that chews up an inode but doesn't really chew up any data is symbolic links.
Mm,
So if you have a whole bunch of symbolic links, you can run out of inodes if
right.
you're overly aggressive with them. All right, so I think that rounds us out, right? Problem indicators on Linux. So we talked about file system stuff twice. Great job, Nate. Um, load average, log files, memory utilization, and process count, which is, like it seems it's a small thing, but like you know what, that could be really telling.
Could be. Definitely.
All right, so Nate, any parting words of wisdom?
Just that we have a bunch of upcoming shows, but you're probably going to cover that in a second, aren't you?
Yeah.
Parting words of wisdom. Monitor your systems. If you don't monitor them, they will let you know in other ways that are a lot more disruptive to your day or maybe your career.
Was it resume generating event?
Resume generating event.
All right. So upcoming shows. Um, we only have a couple of episodes for the year because of some weirdness with the RHEL schedule. So our next episode is going to be on getting and installing RHEL. Happens to coincide with some RHEL announcements that we've made just this week. Red Hat Enterprise Linux 9.3 became GA and available. So we're going to talk about getting RHEL and installing it. Um, then we have a all hands team meeting. So me, Eric, and Nate are going to be like doing stuff in real life. Um, then it is a U.S. holiday week. So after that, we'll be doing our last show of the year, which is messing with your coworkers.
Should be a fun one.
And then we're going to take a few weeks off because we have a few weeks off for our home time with families and whatnot. But
Right.
we'll return after the new year begins. On the other side, we have producer Eric becomes host Eric for RHEL Presents. Next Wednesday is event driven infrastructure with Ansible this upcoming Wednesday. So that'll be the RHEL Presents next week. So thank you. Don't forget to like and subscribe. And if you enjoy it, think somebody else would like it, share it with a friend. Until then, happy into the terminaling, everyone.
Have a great one.